Welcome. In this video, we are going to look at problem 22. It is from chapter 23 of College Physics by OpenStax. Okay, so we have a space shuttle flight. We have 250 meters of conducting tether. This was already considered in example 23.2 of College Physics. Okay. And so we have a 40.0 volt motional EMF generated in the Earth's 5 times 10 to the minus 5 Tesla field while moving at 7.80 times 10 cubed meters per second. And we need to find the angle between the shuttle's velocity and the Earth's field. And we're going to assume the conductor is perpendicular to the field. Okay, so let's write down what we know. We know the length is 250 meters. We know the EMF is 40.0 volts. We know the external field is 5.00 times 10 to the minus 5 Teslas. And we know the speed is 7.80 times 10 cubed meters per second. Okay, in a previous video, we showed that the EMF is BLV sine theta. So we divide both sides by BLV. And so sine theta will be the EMF over BLV. Take the sine inverse of both sides. So sine inverse of sine theta is the sine inverse of the EMF over BLV. And so we get theta is the sine inverse. Okay. The EMF is 40.0 volts. Magnetic field, 5.00, 10 to the minus 5 Teslas. The length of the tether was 250 meters. And the velocity, 7.80 times 10 cubed meters per second. Okay, we want the sine inverse of all that, and we find it is 24.2 degrees. That's what we needed to find. I hope you found that helpful and informative. Thank you for watching. I'll see you in the next one.